energy of friction.
I saw a shirt the other day, Mr. Gottschalk, it said entropy. It ain't what it used to be.
I like it. That's funny. That's what's called humor, students.
Correct. Thermodynamics, heat and energy transfer. You should recall that from the first chapter, the very first chapter when we learned the areas of physics. Sue, what grade? Second, third?
What?
Yeah, we should recall that this is the area of physics that we talked about. Now, the one thing is we're really shifting our focus here. We actually shifted it quite a bit last chapter when we were talking about fluid and thermodynamics, or fluid, I should say, and fluid mechanics. But this will be basically going on a completely different tangent. It'll be along the same lines as the fluid, but it's going to be completely different than the mechanics that we've been talking about with velocity and with that line of thinking.
We're dealing with a different kind of energy altogether.
Correct.
The kind we've ignored all through the year. What happens when friction? Heat happens. Well, now we're going to examine what happens because the conservation of energy is not perfect mechanically.
What have we been discussing for energy?
Mechanical.
Correct. Well, yeah. Specifically,
Moving.
what?
Moving.
With two main types. Kinetic and potential, which are both, as you said, mechanical. What was the definition of mechanical again? Like what did mechanical have to do with? You just said.
The.
Yeah, movement. Right, movement. And so this all has to do with movement. And now we're done. I mean, we're going to be talking about the movement that we're going to be talking about is going to be talking about at the atomic level, and no longer at the
Macro level.
right,
The
essentially
macro level.
macro level.
Sort of quantum, kind of quantum. Recall the definition of temperature? What's the definition of temperature? Because Mr. Hirsch just said we're done with kinetic energy. What's the definition of temperature?
And that was the amount of energy.
Not just the amount.
The movement of energy?
And what kind of energy is movement? Okay.
No, kinetic energy.
Yeah, average kinetic energy, right? It's the average of particles in a substance. So if they're moving faster, they have higher temperature, right? They're moving slower, they have lower temperature until you get down to
Nothing. Absolutely zero.
absolute zero, right? Now, absolute zero implies no energy at all. Not kinetic, not any. Because all these molecules have an intrinsic amount of energy whether they're moving or not. Okay? In other words, they need a source of fuel in order to move in the first place, right?
Yeah.
And so, just like each of us, whether we're moving or not, we have energy inside of us, right? It's a sort of potential energy. We call it internal energy. Okay? All these molecules have internal energy. And that's just the amount they already have. Okay? Everything has to have some kind of energy, and as it goes down to absolute zero, then it loses more and more. It's kind of the reservoir that it loses. So now, temperature versus heat.
What is absolute zero again?
Mine nothing is like there's no movement.
The actual number I think he wants.
Oh, 0 kelvins. Was that
Good. 0 kelvins. Now,
Or
the
negative
one
273.
thing, the one thing that we have to change is it's not exactly negative 273. It's negative 273.18.
Something like that.
This is the chapter where that changes.
That's right. 0.15.
Negative 273.15 degrees C is 0 kelvins. So that's not a negative sign. So make that adjustment in your line of thinking. Does that mean that the transition from kelvins to degrees Celsius is actually off by a factor of 0.15? Yes, technically. It's not exactly 273, it's 273.15. We just rounded to the nearest whole degree when we're changing. But we have zero, none, no particle movement. None, no particle movement. And so basically you have no temperature, right? Look at the definition of temperature. 0 kelvins, absolute zero means no temperature. Because the definition of temperature is average kinetic energy of all particles. They have no kinetic energy because they are not moving. Right. And hence you'd be dead. Anything, everything would be dead. There's no possible life with absolute zero because obviously life would require movement. Beating of heart, blood, movement of oxygen, etc. And so it's a theoretical thing, but it comes into play with differing experiments and whatnot. Also with, obviously, within our galaxy, I should say, depending upon where you're at. Black holes, I don't know, what's the temperature of a black hole?
Very, very warm.
Very warm,
Yeah.
opposite of that.
All right. Am I moving across the room right now? No. Would you say I have any kinetic energy right now? Would you say I have any movement right now? If you look closely, I'm kind of wobbling or vibrating a little bit, you know? If you try to freeze, like you did that play exercise, if everyone is in play, and you saw them do this, they're acting, all of a sudden, she has them freeze, okay? If you look closely, you might see the blink, or, rock a little bit, keep the balance. There's still a little movement going on, right? Well, think of that as internal energy.
It's all relative, guys, obviously. Are you moving? Of course you are.
But whether something is moving across the room or not, there's a certain amount of vibration going on, if nothing else, okay? The resonance, there's some kind of motion anyway. And that's what internal energy imparts. Even if you are at 273 degrees below 0 Celsius, and not that 0.15, you still have that 0.15 above. You still have a tiny bit of energy. Maybe it's not translating to something moving across the room, but all molecules, all atoms, all subatomic things have movement anyway, whether it's vibrational, and a lot of times it's random, okay? And this gets us into things like uncertainty, quantum uncertainty, things like that, where we can't gauge exactly what's going on in the quantum world, the really small world. Once we focus in on one thing, everything else blurs. We'll get into that a little later. But we can't always predict exactly where every particle is going to be. And so it all comes down to probability. And so when we gauge the random movements, that gives us internal energy. So what is the definition of heat then? We're talking a lot about heat here.
Are you hot? I'm hot.
I am too.
We're both very hot bodies. So I've been told, at least.
Maybe it was one of the
That was funny. Saying.
Question, the volleyball game's at 4:30. Sorry, I saw his jersey and I had
Alright, anyways.
I might get in trouble for saying this, but you guys are all hot too. Please don't take that out of context.
Sue is cold. Alright. True or false? Heat and temperature are the same.
What? I think it's because like it can say if something's really cold, you have the amount of heat is not.
Temperature is the amount of heat.
Temperature could be cold.
Temperature is the amount of heat,
False amount.
or is heat the amount of temperature?
Right.
I'm pretty sure we learned in chemistry
If you
that
have kinetic energy and it's caused movement, right? Every time you have movement, you
I
have
thought it was
friction.
like the amount of
Measure of
temperature.
kinetic energy required.
if
So
you have
heat is
friction,
the
you
actual
have
thing,
heat.
but temperature is a measurement.
Think of heat as being average kinetic energy.
Yeah.
Wait, what?
I like the next step.
Temperature.
Maybe help.
Things are
Temperature.
moving.
Okay.
There's friction, there's heat.
If things are moving, there's friction. If there's friction, there's heat.
This is
Yeah.
true.
I concur with that statement.
So what,
So
what
in that
is
sense,
that?
it is the same.
Heat. Why? What happens, AJ? Explain that because you're on the right track.
I can explain it. He's the one who said it.
So is heat not the
Come on, you know how it works
average?
too.
Okay, so I don't know. What
So do you have
surface
you have
is
friction
bumping
within
into-
yourself right now?
Yes,
Why?
because
Very
that part
close.
is moving against each other.
Good. And
There's better examples.
yeah, I know. How much you guys? What's your temperature right now, Mick?
I don't know, 30.
30.
30? Wow, man.
36.
If it's 30, we gotta take it to the hospital. That's really
Yeah,
cold.
36. What's your heat?
I
Does that make sense to you?
Oh.
Yeah,
Yeah? What's your heat?
36.
Your heat is 36.
My heat is negative right now. I feel like my heat is negative.
Yeah.
What?
My heat is negative. And
So
I
it's what you feel.
wait till all yours are too.
Where's temperature's what?
I would.
Heat is heat,
I'm
right?
trying to give you a clue as to the difference here.
And I too.
Well, temperature is a
because-
measurement of it. Heat is.
Wait, what?
Temperature is a measurement of heat. Or-
Temperature is a measurement
Because you
of
don't
heat.
say my heat is blah blah blah.
Temperature is a measure.
I don't know.
Measure of.
The amount. Heat
I would
you have
say
or
if you
want.
reverse that, you're getting somewhere. Heat is a measure of
Yeah.
temperature.
This
Reverse
is-
that, you're getting somewhere.
This is false. Temperature is a measure of heat. But if we flip it around,
And we add one word. Measure of temperature blank.
I don't know.
If you go outside, your heat will
Change.
be more negative. Why?
Temperature
You lose it.
decrease.
You'll lose it. Not just decrease. Any kind of
Change.
change.
I said that
Right.
too.
I was
Temperature
gonna
change.
put loss, but
It can be both ways.
yeah, it's true. Temperature
Yeah.
change.
So,
So-
heat is the amount of energy, the amount of heat, the amount of temperature
No.
gained or lost, the amount of internal energy you're losing or gaining.
Piece of cake.
Oh my gosh, we learned that in chemistry.
Correct. That's why we were trying to hint at you because we don't like to just give you the definitions. Heat is simply change in temperature. And so that's why we don't necessarily talk about what's your heat because it really doesn't make sense. Both are quantitative, but temperature is to net worth as heat is
Oh.
to. I like these things. Think about
Analogs.
This heat's
Temperature
just
to
showing up.
work. Wait, temperatures to
it. Temperature is the net worth
as heat.
as heat is to.
Oh, I got it. I got it.
Temporary worth. Or
Uh,
it's like at that one point. Like
Change in that.
at
way.
one as to pour.
I would say
Yeah, I was going to say income also.
annual income. And the reason I would say that, you guys, maybe this is a little bit above your head. For me, this, I don't know.
Yeah.
Because temperature is the net worth. Your net worth, like what's my net worth right now? Well, if you add my truck, and you add the savings that I have, and you add our pension plans that we're building towards, and you add our 403Bs that we're building towards, you put all that together, that would be our net worth. But then, in a year, let's say this year I moved to China, and I have to spend $1,800 to get back from my roommate's wedding, and all this stuff. I actually end up spending $2,500 more than what I made in the whole year.
So
Then my annual salary is actually negative $2,500. You know, annual income, not salary.
income is not.
Income can be negative.
Let me talking about liquid assets here?
Yeah, we're
But
not talking about
wouldn't
liquid assets, talking about all assets.
But wouldn't
Yeah.
net worth be the one that's changing?
No, yes. No, but net worth is a cumulative amount, just like temperature. Temperature right now is the average amount of kinetic energy within your body. If you go outside today, what's going to happen?
You're gonna get
Sue, this is what we were talking about when you and me and Aaron were running on that cold day.
Oh, you'll die.
You'll die.
Because
But
If
you
Anna
can't
goes
stop.
outside, she's going to die. Don't go outside.
eventually you'll die.
Eventually you'll die.
You'll try to
Exposure,
keep
yeah,
it.
sure.
Your body-
Yeah, I don't know about today, but theoretically, yes, you die. Why, AJ?
So you lose all your heat.
Why?
What about you gain cold, right?
No, you lose heat. So
Lose
it's-
heat.
It's cold.
Gain cold.
Those are, well,
Yeah.
These are the same, right, Nick?
No, there's no such thing as cold.
No game cold.
What do you mean you don't gain cold?
what is cold?
Yeah,
What is
see
cold?
some
The
ice.
lack of heat.
The lack of heat, good.
I'll throw you in the fridge. We'll see if you gain cold.
Oh, it's-
You guys are all correct. This statement's stupid.
yeah.
When I take Henry to the bathroom in the middle of the night, I'll set him down on the bathroom floor, and I'll carry him from his bed to there because he's half asleep, but he needs to pee during the night or he'll wet his bed still. You know, he's got a small bladder. He's only 3.5.
But AJ, I mean, you're
Yeah.
so one day.
I will warn Henry before I put him down. Now remember, the floor is going to feel cold. And why is the floor going to feel cold? Because your feet are going to say, hey, the floor is less cold than us. Let's give it some of our heat. Because they want to equalize. It's all about equilibrium.
That's
And
so
he gets
cute.
it. It makes perfect sense, though, okay?
Yeah, it does.
We have more heat than the air. We say, oh, this poor air is cold. Let's give it some of our heat. That's what our bodies are doing.
That is so
We
cute.
don't have
So
to think
he
about it that way.
shares.
Heat shares, yeah.
But we should.
So when Henry doesn't share it, you go, Henry, you need to be like heat, you need to share.
I should use that. I haven't thought about that. That's good.
Thanks.
So,
I just told
Net
you.
worth.
Discipline.
net worth
Lesson.
is all your assets combined.
Yeah.
Your net worth right now is
But
probably zero because you're less than 18. You might have a little bit that your parents have set aside for
Can
you.
we stop talking about
It
things I don't
change.
have?
Well, it changes as annual income change, but annual income doesn't change because doesn't change as net worth change. So is that temperature change as heat change?
Temperature changes as heat changes.
But heat change, temperature doesn't change?
When heat,
Temperature is based on heat, isn't it?
yes, temperature is based on heat. So when you lose heat, your temperature changes. When you lose income, your net worth changes.
Yeah.
When you gain income, your net worth also changes.
But how about the net worth to the annual income? The temperature change.
Don't overthink. What?
You gotta go. You gotta
Yeah.
go.
Okay, you go.
All right.
All right. So remember, for torque, we had two conditions of equilibrium. We had to think about force up and down being the same, or force left right
Oh,
being
yeah.
the same, and then torque counterclockwise, clockwise.
Yeah.
Or as another form of equilibrium here, thermal equilibrium. Okay. And again, nature, just like everything else, heat wants to transfer and be the same. That's what causes weather pattern. That's what causes air currents, heat rising, cold sinking. It wants to all equalize. Okay? So thermal equilibrium. Again, nature craves equilibrium. And in this case, it craves to all be the same temperature.
Mick, do you know what that means? Nature craves equilibrium.
What does it mean to crave
We've
something?
talked about that all year. Right now, I crave my coffee. So I'm going to get a drink. Crave means you very much want.
Usually we talk about it with food.
Right. Usually we talk about it with food. You crave. At
Is
11:30,
it something
you're
that you
craving
haven't had?
that sandwich in your locker.
Is there something you haven't had since you left Thailand that you're craving some kind of food you can't get here that you just really, really want?
Pad time. We talked about this last night.
There we
Yeah.
go. All right.
No, so it craves equilibrium. And what does that mean? That means that right now, you are actually battling nature. I am.
That's
We all
awesome.
are, and it's a losing battle. That's
It's
why
like-
we need to keep drinking coffee and eating food, so we generate more heat to equalize what we've already lost.
So
Right.
really, nature's trying to
Replace.
take away our energy.
Yeah.
Well, if
How rude.
I'm battling it, yeah, there's so many senses in which you're battling it. I'm battling it right now because if I fell asleep right now, what would happen?
Fall.
I'd fall over to the
Oh,
ground,
I
probably, I would say. because I'm battling gravity right now. Gravity constantly wants to pull me to the floor. And it doesn't want to just pull my feet to the floor. It does want to pull my feet to the floor, but it wants to pull every part of my body all the way to the floor. Okay? To the point where the whole thing's sitting down there. So we're battling gravity there. We're battling heat on a daily basis. If you go outside, what does your body want to do? What does the heat within your body want to do? It wants to heat up the whole stinking atmosphere. And that's why you would die. Because if you go outside on a 30-degree day, your heat is so tiny relative to, obviously, the atmosphere.
You know how in the summer, if you leave the door open, your mom says, hey, we're not trying to cool the whole neighborhood here.
Yeah.
Well, that's not exactly true. But
The neighborhood's trying to...
the whole neighborhood is trying to heat you.
Your house, right. So, it's interesting.
And that's, houses that are not airtight. We have problems with efficiency, problems with airtightness. This room, or this building, is a sieve of energy loss. Okay, all these big windows.
Single pane windows.
I love these great windows. They're great for light. Actually, when the sun comes in, we get a lot of energy transferred in here, right?
Oh, yeah.
But they're very inefficient, and that's why if the heat's been off all night, even if it was 70 degrees in here last night, you come in and it's 50 the next morning. Maybe that's a little bit of exaggeration, but that's the way it is. We don't have good insulation. Glass does not provide that. I'm guessing 100-year-old building is not very good insulation in the walls either. So heat is transferring through all the substances trying to equalize. From basically the air outside is cooling the brick. The brick is cooling the drywall. The drywall is cooling the air. Remember, it's the opposite. Okay, the heat is slowly trickling outward. Sue, what?
I can't see anymore if he keeps writing smaller.
You don't need to write this down.
Good, because it's not true. The Earth is not spherical.
No?
It's an oblate spheroid. It's slightly flattened at the equator due to spinning.
So not at all? Or don't need
It's
to
fine.
write?
It's inconsequential right now. I don't know what that word is after rotating here. What does it say? Everything. Is this another true or false here?
Wait, what?
Reasonably.
No, it's not.
But I still
This is
can't
Mr. Ernst. This is so far from the truth.
It
Yeah,
doesn't
but
You know
make
what?
sense.
Longer.
Mr. Goshler's getting fired up.
Let
now.
me explain.
Can you read it?
Night.
Yeah, hold on. Can Sue read it first? If the Earth were not spherical and rotating, everything would be the same temperature. And it might not be true, but I'm going to make a point. I'll let Mr. Gottschalk explain how stupid that statement is, but then I'll make my point. So go ahead, Mr. Gottschalk.
All right. Well, what would happen if
How does the world be so
if I stand in front of the sun and the window the whole time?
You'd be looking 200 degrees over your
Facing the
sauna.
All right. If you stand in front of a nice sunny window with your back to it, your back is nice and warm, right?
Oh,
Does your front? No, your front never gets warmed, right? So that's what happened in here. We got all this infrared light, which is what gives us heat, hitting this side of the atmosphere, and this side is getting nothing.
Yeah, but sure.
This ground is getting lots of heat. This is getting no heat. What does that cause? 600 mile per hour global winds. As all the heat tries to rush over the dark side. Okay.
All right, now, Mr. Gottschalk, you're premising off. I said if yours were not.
I don't care if it's spherical or not. If it's not rotating, you have a huge temperature differential between the light side
So
and the dark
what?
side.
Yeah. How would you still get like
Here. So the Earth is a plane.
just
And-
a two-dimensional plane
Yes, just a two-dimensional plane. We have no thickness. Here's the sun.
directly above it?
Directly above it. Exact same width.
Okay, Pope Innocent the 13th.
Exactly.
Go for it.
I'm going off of what they thought in the medieval times.
Yeah. Except
But
they need to have a coat on.
my point is simply this: is I want to exacerbate on, or I want to elaborate on the nature creates equilibrium statement. Is that constantly the ocean and the air and the world is trying to achieve the exact same temperature, but the sun does not allow that. The sun is our source of everything. If it weren't for the sun, we'd be dead. Yes?
Mm-hmm.
Two main things we need, sun and water. If one of those two ever ran out, screwed.
No, we're wrong.
Even if we had water, we still be without the sun because the water will frozen.
If the sun is done, we'll run out.
8 minutes later, correct. But either way, we rely on the sun and we rely on water. Frankly, water relies on sun anyway. So in the end, it all goes back to the sun. That's why some of the first civilizations had, the sun gods. They realized that, we realized that. But the sun is our heat source. And the fact that, you're using, Mr. Gottschalk, when he shows his earth science class, just the atmosphere, he'll put a flashlight and then he'll rotate around. Well, what's the difference with the sun? The difference is direct light versus indirect, dark versus night. Our seasons are caused by how direct the sun hits us. Does it hit us directly? Does it glance off? The slant of the earth? Does that make sense?
It hits the equator relatively perpendicularly, so you have a huge concentration there. Okay? Think about torque.
Versus
perpendicular is the best.
Versus if it hits us.
If it hits up here,
right.
You have a wide angle there.
It's going to glance off.
Yeah.
And that's essentially what causes our seasons, is the tilt of the earth. Well, what the sun essentially wants is to heat everything the same. The sun wants to impart its heat on the whole world exactly the same, but because the earth is rotating and tilting, it doesn't. Now, nature craves equilibrium. My question is, why is it colder in space than it is on the earth?
The particles aren't moving as much.
What?
Well, yeah, that's why it's colder, but why?
But why? You know what I'm saying?
Oh,
Think about, right here, let's say this is the sun. Obviously, this is not proportional, but I will tell you it's colder right here than it is right here.
Yeah, there's less particles for anything to hit off.
Right, but even those, remember, it's to measure the average movement of the particles, so there are some particles there. Why is it still colder anyway?
And this is going to really lead.
It's colder if it is colder.
It is colder right here than it is here. This is closer to the sun. This is kind of going to lead into what is this heat temperature thing? How does it work and why? And yada yada yada.
There's less particle to transfer the heat to.
Yeah.
I'm not quite sure what you're getting at here. I agree with it to an extent, but I'm not quite sure what you're getting at.
There's less particles for the heat to transfer to.
Yeah.
What I'm getting at, this whole heat and temperature thing is dependent on a lot of things. We talked about specific heat before, right? What has a high specific heat?
I remember this, I just don't remember.
You remember what substance has a very high specific heat? Agua, water, has a very high specific heat. What is specific heat? Nobody. Alright, we're going to talk about that later. I was hoping you guys would be able to answer this pretty quickly. Essentially, because the Earth is its temperature, it's going to stay at its temperature because it's made up of a lot of water on the surface. And also the Earth, because it's a body and a large body in itself, it has a certain amount of energy within itself. So it's not just the sun that gives us heat, correct?
Yeah.
The Earth within itself. Our core is very warm.
There's radioactive decay down there. There's a lot of friction and heat because of the pressure, just pressing down on everything at the core.
Does that make sense?
Yeah, but I was thinking about something about atmosphere.
Atmosphere, correct. It does have, what you guys said.
As far as generating heat?
What?
Does the atmosphere generate heat? Is that what you're saying?
They hold the heat.
It holds the heat, yeah, greenhouse effect. Yeah, that's why it stays warm. On the moon, the dark side of the moon, no atmosphere, is always about 200 degrees below zero, where the light side of the moon is 200 degrees, 300, 400 above zero.
Right.
Because there's no atmosphere to equalize. The atmosphere is like a buffer. It's like, in order to not burn myself when I take a hot bagel out of the toaster, I run my hand under water first. Okay? And that little film of water serves to sap a little bit of the heat from the bagel so my hand doesn't get burned. Okay? It's kind of like wearing a hot pad. It's a buffer, right? The hot pad starts to heat up, but it holds some of that heat from getting to your hand.
Although nature craves equilibrium, it will never be, if it were set, we'd be dead.
Okay, look at one thing for us tomorrow. Well, make sure you've read 10.1. Look at page 361. There's a temperature conversion for Fahrenheit to Celsius. Just reverse that for us. Solve it for finding Celsius temperature.
Like 5 nines times the quantity, F minus 32.
Yeah. So just change that. Solve for TC. Solve for Celsius temperature for tomorrow. No other homework. But just read the section.